Hey, buddy. It's a weird pre-recorded version of this show, so we don't have any of the jackals in the chat throwing us off this time.
It's going to be so nice to be able to just have a conversation with all those hooligans harassing us with funny comments.
Zero peanut gallery, no title suggestions. We're doing it all ourselves. Yeah, that's great.
Yeah.
That's great.
Yeah. That's how
what do we got today? We got a friend with us.
We do, yeah. We've got Paul Niles with us from NASA Johnson Space Center. Paul, welcome to the show.
Hey, thanks for having me.
Well, thanks for inviting yourself onto the show. We really needed it, actually. yeah. So we've had a lot of conversations on this show recently about the Eclipse program, the Commercial Lunar Payload Services program, and we're always kind of just shooting our mouths off because we know a little bit what we can read in articles and stuff. But I've had you on We Martians before, and you sent me an email. I was like, hey, I can come on and actually show you some of the things that are actually going on with some of these payloads. And we were like, thank you, please, yes, this is what we actually want. Thank you for giving us this opportunity. So we're excited to talk about that today.
Yeah, no, I'm super excited to be here. And I was just listening to, I'm a listener, longtime listener, and felt like there was a story that needed to be told. So I hope I can.
Great new model for us booking guests on the show. Loudly shout about things people work on. Have those people email and be like, I should come on and help. And we're like, yeah, this is great. So I just want to put the call out that this is a great model, and you could just hit us up.
Yeah,
so.
Yeah, exactly.
Jake, before we even do drinks, I think you should talk about something up at the front of the show so people know what's going on, since we're getting close to eclipse time.
Yes.
And I think there's a website I'm supposed to pull up about this.
Yeah. So we are go for having a little bit of a pre-eclipse meetup. So if you are traveling to where I'm going to be for the eclipse, so that's going to be in the Niagara region of Canada. So if you're up in St. Catharines, Niagara Falls. St. Catharines, Niagara Falls, like kind of that area, Buffalo, even if you want to cross over the border and come say hello, we're going to have a little bit of meetup. That's Sunday, April 7th, which is the night before the eclipse. So you can go to offnom.com/discord. No, that's not it. offnom.com/events. That's the one we're going for, /events. And that's where you can get the... you can go to Discord.
You could go to Discord and then go in there and ask, but that's not what you want if you want the address to the place.
yeah, exactly. Yeah. So it's kind of my old stomping ground, so I'm really excited because the eclipse is going to pass right over it, and I'll be there.
I'm going to be in Dayton. I am taking my son out there, so I'm not confident enough to book a meetup destination, although I am the day before planning on going to the Air Force Museum, which I've always been dying to go to. And I realized the other day I probably should go to the Wright Brothers stuff while I'm there. Like, they have the little cycle company. I don't know if Paul, have you been to any of these things at Dayton? I don't know if this is a thing people have been to. I don't know. This Air Force Museum has a full-on Titan IV, just like sitting in the museum. So, and the Valkyrie. So I'm pretty pumped to go see this stuff. So if you're going to be in the Dayton area, hit me up. And if you don't mind going to see a bunch of rockets and airplanes with a very excitable, almost 4-year-old, then we'll be there the day before. It'll be great.
Awesome.
I was teaching him how to use Eclipse glasses this morning.
Ooh.
I gave it to him I was like, maybe we should start practicing. So I handed it to him on the ride to school. Like, you got to look through this. You won't see anything but the sun. So practice finding the sun. And he enjoyed it quite a bit. So it's going to be good.
Awesome. Okay.
Anyway, did you bring a drink, Jake?
I did. Yeah. I have another one from The Beer Company at my favorite store around here. And this one's rad. Check this out. Look at this.
What?
Pepino Espacial. It's a space pickle.
Wow.
Space pickle blonde ale. So I don't know.
With sunglasses and a visor.
With sunglasses. with Eclipse glasses on. He can only see the sun. So this is what I'm having today. I don't know what it is. I don't know. No idea if it's going to be good or not.
So good.
These local beers are really expensive now too. Like, they're really climbing up. Like, I think this bottle was like $9 or something. So
it's because they're like, we got some new customer in the region.
Yeah.
Gotta start jacking these things up.
There's this white guy down here who will buy anything we put a label on. So just
put a space helmet on this thing.
Yeah. So that's what we're doing.
Paul, did you bring anything with you there?
Yeah. I've actually got two things, if that's all right.
Wow.
Well, one's empty, so that's why I brought two.
Nice.
But I felt like it needed to be mentioned. So we've got the Bent Run Moon Hopper.
Nice.
So Bent Run Moon. So this was actually from a pallet of beer that was delivered to Astrobotic during the mission. So I was, coming in and doing our operations, and one day there was a pallet of beer, like a pallet, like it was stood several feet high, and I was impressed.
Could it have fit on Peregrine to the lunar surface, or was it more than that? That's what I want to know. More or less than the payload capacity?
More than the payload capacity. And then so the one I'm actually drinking, this is Space Train, local Eureka Heights Brewing. That's a Houston brewing company. So.
Wow. I got a Texas one, so there's that.
Ooh.
I've got the 4th of our Starbase Brewing batch that I've been drinking. This one, I like the name of Kolsch, I Still Love You. It's the best name of all of them.
Nice.
It's the best name of all the beers. So I haven't gotten to this one yet until now.
Wow.
Yeah, that's great. It's a really good one.
That's really funny.
Yeah.
I have something to report about Pepino Espacial. It is not just a gimmick for the label. There is definitely pickle in this.
Oh, wow. It's like a pickleback.
It was fun to discover. Yeah.
Mm-hmm.
Yeah.
Wasn't expecting that.
All right. Well, then with that, we're rolling here.
We're rolling. Yeah. So maybe we'll start, Paul, do you want to just tell us what your job is and give us your credentials so we know what kind of context to put this conversation is? What do you get to do at your work?
Yeah. So I joined NASA in 2005. I'm a geochemist. So I worked on Mars geochemistry, so Martian meteorites, to start my career. And then I worked on Phoenix and MSL as a project on the science team for those two missions. And then in 2019, I was asked to join the Eclipse project office here at Johnson as the scientist in residence at the time.
Gotta have at least one of those on the program, right?
Right, that's exactly what it was. You guys should have a scientist in it. Now, I mean, to be clear, the project office is the sort of that's how we execute all these task orders at Johnson, and then there's a headquarters office which handles a lot of the programmatics. So there are program scientists and scientists involved there. So it was the next step down. You might understand why people might think, hey, we don't need a scientist on the execution side, but I think that we've shown that having scientists involved has been really, really important. So I've been involved in the Eclipse office since basically it started. It's been a fun ride.
And you got to work on kind of both of them so far, the ones that have flown, like both Peregrine and Odyssey.
Yeah, right. So I was the
Odysseus, you Mars elitist. Jesus.
Oh, whatever. Odyssey. Yeah, sorry. I got all the Mars gear on.
I know.
Me, and I got Red Planet on the brain here. I should lean over and cover that one up there.
So I was the project scientist on Peregrine 1 mission, and that was the lead project scientist. And then I also supported the project science on the IM-1 mission. I've been able to participate in operations for both missions.
That's cool. That's great.
Can you explain the difference of the two offices that you mentioned between the stuff that goes on at Houston, the stuff that goes on at DC, and like, I just always have a hard time getting my head around. Because I think there's the program manager at Johnson, right? Chris Colbert, if I remember correctly.
Project office manager, yeah.
Okay, project office manager. And then, so what's the DC side? It's like how it fits into the science mission directorate, or what's the breakdown of responsibility?
Yeah, so it's the office is called SEO, ESSIO, and like most acronyms at NASA, I don't remember exactly what it is, but it's Exploration Science Integration Office, I think. That they basically have the budget that runs, and that's Joel Kearns' office. That they have basically the budget that runs the Eclipse enterprise, amongst other things, and they are staffed with program scientists as well as program executives that help sort of manage the whole process. So the budget comes in through them, and then and they help for sort of the formulation aspects, mostly on the Eclipse side. And then once they've formulated a particular task order, got together a set of payloads that they want, They hand it off to the project office. The project office writes the request for proposals, and they're mostly involved in the vendor relationships. So they handle the RFP and then the request for proposals, and then the reviews that go through for the vendors. But as far as payloads are concerned, that's all formulated at the headquarters level. Obviously, project office folks have some input in the reviews, but that's not managed by us directly.
Interesting. Yeah, I mean, it's kind of an interesting process, right? Because you've got like all these sort of disparate payloads that have to come together, and I think that I'm sure the ultimate dream is just like you could just reach into the bucket and grab whatever payload you want, any 10, and they would just fit on the spacecraft, and it would, like, you wouldn't have to think about it. But that's not actually true, right? Because you've got like, different sizes of payloads and power requirements, mass, and then of course like the science they want to do, like, do they need to be on like a specific side or the top of the spacecraft, or can they be inside? What part of the moon are they useful to study in? So like, what does that look like to sort of select your palette? Like, how do you put that together, and how is that, what part of the decision tree does those two offices and all the scientists and everything, where does that all fall together?
Yeah, so the original, if you guys remember the shots on goal aspect, that's when Eclipse first got stood up. And these first two task orders were part of that, sort of this initial phase where they wanted shots on goal. And so they basically asked both NASA and academia, what are the payloads that you guys have lying around that we can throw on, right? And we literally just told the vendors, you could fly whatever you want. Here's a list, pick, So the goal of those missions was much more of, let's get off the ground quickly. Let's make these things happen. And the science was sort of riding in the backseat. But as we move forward, that has progressed. There's been a lot of interest in obviously making more targeted science investigations. So the PRISM process, it was stood up at the headquarters level, and that is that's a program where they're really trying to accomplish decadal level science, and it's really kind of a mini discovery kind of a process where they're asking for suites of instruments that will accomplish comprehensive science goals, and that comes with a landing site too. So if a PRISM payload is picked, it gets to sort of select the landing site that it wants to go to, and it's got a set of payloads that are attached to it. Now, what can happen after that PRISM payload is picked is that the additional payloads are added on, and that can happen sort of in the process of the formulation. So that has resulted in some interesting combinations. And once you kind of have an idea of where the spacecraft's going, then you can really think about what payloads go well with it. And I'd like to think that one of these days we're going to have sort of the Walgreens, the Walmart or the Amazon superstore of payloads, and you could just sort of formulate these missions by putting together whatever you've got, whatever's sitting there on the shelf available, ready to go.
Add to cart, right?
Yeah, exactly.
The PRISM thing that you're talking about that's like I'm curious to just understand how it actually works. Is that a person or group of people that put together the proposal and one of them gets selected to go forward, or is that like a committee that puts together a bunch of PRISM-like ideas?
Yeah, originally it was actually targeted. So they said, hey, we want to go to this spot on the moon. Give us your best instrument suite. And so what happened was they asked the science community to do that. Science community, there's a variety of scientists get together into teams, and led by
they're like PI led, right? Like they're
PI led, yeah, exactly.
Okay.
So it'd be a PI led, instrument suite to attack that particular problem. I think that was for Grootides and Domes. I think that one was the one, which you're gonna have to forgive me. They all sort of run together. I think that's the CP11 or 12, one of the two. Anyway, forget it. Never mind. Let's not get into the nomenclature. that we
I'm Googling.
that's a really long story, and it doesn't need to be told. It's not worth it.
Okay.
Yeah, so the Grootheisen Domes mission, that one was originally that way, and then what happened for subsequent ones was, hey, let's we'll be open to any landing site. So propose your best science and your location. So that turned out to be, I think it allowed for a lot more robust competition amongst various PI-led instrument teams.
That's interesting. So I don't. There was that's almost like an anchor payload, really. Then, right? Like this prism thing would be like sort of like a core. Like we're building the science around this one thing, and then we're just everything else is ornaments that go on the tree, right?
Yeah, exactly.
Huh.
Makes me wonder though that is that level, because that's lander agnostic at that point. They don't have a they're probably payload classes, right? You got 100 kilograms, 500 kilograms, whatever, but it doesn't matter what lander their proposal matches to.
Yeah, exactly. So this is all before we've selected the vendor, and so the requirements of the payload are written into the request for proposals to the vendor, and so the vendor's proposals have to correspond to the requirements that we have developed on the payload side.
It makes me wonder about a future version where we have a couple landers that are actively working. If the landers would get pulled into that package as well, where it's I'm going to do this mission with this lander for this amount of money, and you're going out and winning the whole set, because there might be certain vehicle features or capabilities that you'd want to take advantage of, and at some point down the line you'd be choosing between full-on sets, right? I'm just curious if that is something... Yeah. Structure-wise now probably doesn't make sense, but does that track with a future possible direction, or are there more benefits to the agnostic nature of these suites than there would be for a fully integrated thing?
I think that the selection of the lander, or matching the lander to the payload set, happens in this proposal process. So the requirements are written as part of the RFP. There's a free and open competition, and then if one of the landers turns out to have a better design that suits these payloads, then that kind of comes out in the process. You could see that various aspects of the mission become really hard for some of the vendors based on the requirements that we're placing. So, and we want to be in a situation where we have a good competition, so we're not putting these requirements that are so excessive that only one vendor can get.
Your name must start with I and end with S. Otherwise,
yeah.
But how does that match to if there's a world where Astrobotic has a whole line of landers that make use of a lot of the rovers that they have? There might be people out there that have ideas for certain instruments that would also be helped by having 3 or 4 rovers that can do secondary tasks or something. Would that be something that would be part of the requirement? You have to put this payload on a lander, but then there's these other payloads that need mobility. Would it be abstracted to that? And even if there is only one that matches, at least you're sending a signal to the market that, hey, Intuitive Machines or whatever, you should develop a thing that kind of matches this capability, because people are realizing that they could take advantage of that sort of stuff. Is that more shaping the direction, or is that even then too particular?
The first Grootheisen Domes Prism call, actually the proposal that was picked had a rover that was part of the whole suite. So they proposed a rover that would be part of as a payload that they manage. Then at subsequent Prism calls, we actually said, hey, if you want to use a rover, we're going to have a vendor provided rover. So they didn't have to pay for the rover itself, and the vendor provides the rover. So we're actually trying 2 different methods on that, and we'll see how it turns out. I think the jury's still out on what the best way to do this is.
Yeah. I mean, there's just even just talking about this, there's all these different things that are popping into my head. What if this? What if this? What if you've got payloads that need to be subbed out after the task order has been awarded, right? You've got whatever, some payload falls behind, and it's we're not going to make the launch, and you pull it off. Then you got to go find another one, but the lander and the mission's already been picked, and so you have to narrow your set that way. And yeah, there's all sorts of like weird things that kind of shake out when you're trying to put together these missions in such a Lego brick kind of way, right?
Yeah, yeah, yeah.
Huh.
And I think it's really just one of the great things I've really enjoyed with this is the ability for us to sort of learn as we go, because we have so many iterations at this. We're like in a way we're kind of like the vendors themselves in that we're learning what's the best way to put science together on in a structure like this. What's the best way to have in this situation? I mean, we've definitely had these situations where, payloads are, maybe they get taken off, maybe we want to sub them out. Like, what's the best way for that to happen? How do we get the best science out of the resulting mission, and things like that? So, it's really the process of just starting with the shots on goal environment and moving to more and more science heavy missions has been really helpful in making sure that we get things right. And we're still making mistakes, so we're always hoping to make better mistakes tomorrow. That's the
Same, which is why we brought you on this show. What did we get the most wrong? What made you stop your car when we were talking about this last time and email us?
No, I don't think there was anything major. It was just like from the project. So one of the things that we developed, that I helped develop on the project office, was a role called the project scientist. So the project scientist is the job I did for Astrobotic. We have a project scientist for each one of these task orders, and their job is to sort of shepherd all of the NASA payloads through this whole process and through operations. So our job is to make sure that the NASA science gets done as best efficiently and and effectively as possible. And that's a job that I sort of felt like you guys were sort of there was some misunderstanding about how that was being done, and I wanted to come on and just say, hey, no, actually, science has been a big part of how all of this is being considered and being formulated, and even all the way through the operations. So we're there in the vendor facilities, interfacing with the vendors directly and helping to make sure that those science operations go off the best way possible.
So you mentioned there's like, okay, these first two missions, it's like, what do we have lying around? Let's get some stuff just kind of going so we can try this out. And then you've got these Prism calls coming in that are presenting sort of new purpose-built, payloads or payload suites for these kind of things. The stuff that gets added after, is that still coming from the sort of, the Kmart bin of stuff we have in the back room? Or is there going to be like new proposal opportunities for stuff coming in to the not anchor payload? Like, and how does that kind of work? I'm kind of curious what the pipeline ends up looking at. I know there's probably like a backlog to start, but presumably if you fly a couple of these a year, you're going to clear out the backlog of instruments reasonably quick. I don't, you tell me, is John's going to have 100 instruments lying in the background somewhere? I don't know, but like, what does that look like from a pipeline perspective?
As far as I know, I don't think we have anything like super lying on the shelves. We don't have a storage room or anything yet. I'm hoping for that Indiana Jones warehouse one of these days.
I don't know. I've been in whatever building Resource Prospector was in, and that sure looked like a storage room if you ask me. There's just a lot of random stuff around there.
There
it was like the scenes of programs gone by. There's that weird rover that's always the pressurized rover with the that thing. Like a lot of weird stuff in there. So you should go in that building if you don't think there's stuff lying around.
Building 9, yes.
Yeah, Building 9. There you go.
We don't have a Eclipse warehouse yet. So
there you go. We're gonna start taking stuff. Fly the Resource Prospector model that was in that building. Just send it there, test it out, see what happens.
It's got to be fairly super cheap. So there's a manifesting board which is run at headquarters level, and STMD and ESDMD, so human exploration technology. All of those are participants in that, and so in that through that board, then a variety of payloads can get flown. And as you've seen, we've got not just SMD payloads on these missions. There's SDMD payloads, and
Mhm.
and I don't think we have a ton of ESDMD payloads yet, but maybe one or two. But yeah, I mean, there's a lot to keep track of. We have over 40 payloads that have been uh, that are on track to be being flown, and so, and one of the interesting things is that we've actually got multiple copies of several of these as part of this manifesting process. It was like, hey, we need more than one copy of this this instrument to add on to one of these other payloads. So there's been a lot of opportunities to get other payloads flown multiple times. So I think that's a real boon to the whole philosophy. Which is the other thing I wanted to talk about here, but I don't know.
I have a payload question real quick, though. You mentioned that there's stuff that was existing or things that you have multiples of. Thus far, how did those payloads become themselves? Like, how did they end up where they're at right now? Did they fall off other programs? Were they things that have flown previously, but there were spares? Is that a, like, complete happenstance right now that you have ended up with these payloads that are available, or is there a process that those things are constantly getting developed and slotted in when the time is right within the agency?
For the spare one, these first set of payloads that we got from academia and from NASA, the ones that were just sitting on the shelf, that's
what I'm wondering. Like, what the hell is this shelf? Why do we have a shelf of moon payloads? Has been my question all along.
Yeah. So a lot of them were instruments that flew. Either they had an engineering model that was flight ready from something that had flown before, or it had been developed for a mission that never went, or it was a copy of something that had been flown multiple times. So the LETS instrument, for example, on PM1, on the Astrobotic Peregrine mission, was a radiation sensor instrument that they've flown on Orion's and multiple other missions. So just building another copy was like pretty straightforward for them. So while it maybe wasn't sitting on the shelf, they had all of the parts. They knew exactly how to build these things. It was able.
All the NRE was done on it, so they just need to manufacture one. Yeah. Okay.
Yeah. And then. And then another example would be PITMIS, which was the one of the ion trap mass spectrometer that was on Peregrine. That one was originally part of an ESA payload, an ESA rover. So it had already sort of been developed, and there was a partnership between ESA and NASA Goddard to bring that forth. So that that's how these things a lot of these things are sitting in that valley of death, right? Like you have the TRL, the TRL like 6, 7, 8. You get funding programs that get you up to that stage where right before flight, but getting that instrument to a flight level readiness is sometimes pretty hard.
It's hard. Yeah.
So is there a idea, or is it possible within the structure of CLPS that there might be a funding track focused on CLPS for lander agnostic payloads that as Jake's saying, if you clear out the backlog really fast, if everything goes as we envision it, and there's a bunch of these, you're going to be pretty empty after a couple flights. So is there now that we have this path, is there a funding or development pipeline that can be set up to develop a string of these and kind of bulk buy useful payloads and restock the shelves rather than just letting them get restocked by way of program cancellations, which is the saddest way to stock the shelves?
I think there is an effort afoot to do some standalone instruments. So Prism have an additional program alongside the Prism process where we developed these standalone payloads that could be sort of picked. They would end up on the shelf, and then you would be able to pick them for a mission. So that is something I think is really close to coming out. I'm not sure what the status of it is. Obviously all this budget uncertainty has but that's definitely something that
could develop a lot of payloads on the shelves. Some would say
that idea has been thought about a lot.
Yeah, we're not cutting the budget. We're stocking the Eclipse shelves. Okay, that's what's happening here. We can't fly these Venus parts to the moon, though. That's the thing, Jake. You know, we can't fly these Mars sample return vehicles to the moon.
I mean, that's actually a question that I wanted to bring up. How flexible can we make this program? And we're getting, we're trying out this sort of like, location on a body and vehicle of transportation agnostic. Like those are variables that you don't get to lock down now. Just kind of make some proposals, but like, could we have a sense like, here's just a payload that will work anywhere in the solar system. I'm just looking for a ride to somewhere,
Yeah, no, I think that a lot of the payloads that we've got actually were on missions that were going other places. So, obviously the radiation sensors are things that fly at a lot of places. There's actually a lot of payloads that are like the mass spectrometers. They're pretty useful no matter where you put them, and they can be used in different ways. So actually, that's kind of an interesting. It's really interesting thing as to how you could recombine things. Now, sample return, I've got a half-baked idea that I've been trying to get people interested in, but it's my own personal.
Let's do it.
This is the best place for a half-baked idea. So
yeah.
Everything we say is half-baked.
Let's work this out. Yeah.
This is not a NASA.
No. But if this works, we're putting an off-nominal sticker on it. That's that's the only rider. We'll let you roll it out here as long as you agree to that.
If you're listening in from NASA HQ, just cover your ears for a second, and then we're gonna hear this great idea.
So
spin launch. And he's gonna roll out spin launch right now, Jake. It's gonna happen.
So the question is what if you could take advantage of the Eclipse program to help deliver some of the sample return payloads? So instead of flying one sample return mission, you fly 8. So you build 8 copies of it, and that way you get the savings from building many copies, and then also you don't have to worry so much about it working the only time that you fly it. And then, it's sort of like the Mir rovers. We always say the Mir rovers cost, $400 million each, right? But they were $800 million. That really was $800 million because there were 2 of them. But you were able to divide that in 2. And so you could use that as the number. Or if you could divide the sample return payloads by 8. And take advantage of some of the aspects of the Eclipse model to deliver these payloads to the surface. So that's the half-bake idea. I think that there's a lot of baking that needs to happen as far as how you split up the different aspects, and the is the rocket Eclipse provided? Is the ascent to space Eclipse provided or not? Is the how did the sampling happen? Do you have a rover that goes and collects samples still? But anyway,
how many helicopters? That's a major thing.
Yeah, exactly. Are the helicopters vendor provided, or are they NAV provided?
No. I'm just thinking about budgets, and I'm like, we always keep there's this JPL RFP about what's the thing called, Jake? It's like the commercial Mars services or whatever.
Yeah,
it's more than just landers.
Yeah.
But I mean, if
well, it isn't landers, to be clear. It's
not landers.
They're tipping their feet in the water for like orbiters and comsats and things like that, right?
Okay. Well, I'm just saying, if we did an equivalent budget on this half-baked idea of Paul's, and we're like, here's the Mars sample return budget, divide it by 8 and award that to 8 companies. Do you think none of them would work out to get something down to the surface?
No. You don't want to do 8 companies.
That's a ton.
Bad idea.
All right, 4. Fine. Everyone gets 2 shots. Everyone gets 2 shots.
Yeah, you gotta build it. You gotta split it up.
That's even better. Then they're gonna get how much is
shots
what's the latest Mars sample return budget line, Jake? On that estimate,
950 is the max they can spend this year, right? 950 million. Yeah.
$2 billion a piece. Like, figure this out. Get to the surface and launch something off of it. It's just then all the other stuff, right? Get it back and do the thing and.
The thing that I always think about Eclipse, which I really like about it, is that at the end of the 10, we've had these sort of 10-year master contracts. At the end of the 10 years, it's not like it's the end at the end of a sample return. If the way, we're currently formulating it, we're going to be done. And then if you want to do it again, you're going to have to do it all over again, right? But with Eclipse, if the end of 10 years, all of a sudden, all of that money you've invested it into a capability that you can now take advantage of at a much cheaper price with much more reliability, because my assumption is that these guys are really smart, the guys and gals that are running these missions, and they are incredibly, they have the capabilities, we have the technology. It's just really a matter of if rather than when they're successful, and they have developed this capability that we'll be able to utilize. And at the end of these 10-year contract we've got, we're going to be able to take advantage of that, and we'll be able to build on all of that progress that we've made. Yeah. So it's really much more of a build-up process, which is not. I mean, we have a little bit of a build-up, with the planetary missions, because we're able to utilize various technologies we develop in one for the next one, but it doesn't save us so much money as it could possibly.
Yeah, the resulting asset is not as obvious as the resulting asset of a full-on Intuitive Machines that has flown a handful of times to the moon.
Right. Well, I mean, it's hard, right? Like, I mean, to think of even something what's a spacecraft we've flown, like, from a planetary perspective, like, the most, and it's like, the things that come to mind are like things like, the Maven bus, which is also OSIRIS-REx, which is also like, there's a few things like that. There's like the InSight /Phoenix /Mars sample return lander, like that's common bus. Even just like the aeroshell that goes to Mars, we've flown that roughly that same thing, like a half dozen, 8 times.
All these Canadarms.
Yeah, all these Canadarms. But you don't get like mass production benefits when you make 5 or 7 of these things over 20 years. Like, you don't get any benefit with that, right? And then of course, like, there's no one else buying these things from NASA, and so there isn't like a market incentive for, say, Lockheed Martin to like find a way to do this aeroshell at 1/10 the cost and sell it to 100 people. Like, there's no opportunity to do that. Why would they, right? And so, yeah, I think you're right about that. Is that it's tough. But I mean, this idea sounds a lot more baked than you made it out to be, Paul. I'm gonna call you out.
No.
Because it's smart. That's like one of the biggest criticisms of Mars sample return, right? Like, no one's disputing that doing it is not worth it, as it's like the most critical science that the planetary science community has agreed this is number one priority for like 30 years. Like no one disagrees this is the top thing that we should be doing. But how we do it is a whole other thing, right? And you're right. Once we're done with this, it's done. And then that's it. None of this is reusable in any kind of way, right? So maybe $10 billion is worth it for Mars sample return, but to only do it once and then not have anything left to show for it except for that one ounce of science, it's tough, right? It's a tough pill to swallow. Whereas if we had something, that we could use over, it's exciting to think about.
This whole distributed sample return from the moon thing would also please a lot of the people that are like, look at all these technologies that are transferable from the moon to Mars. Like, you would certainly feed forward whatever base technological jumps you need to make in terms of getting that rocket to the lunar surface and how it interacts with the lander itself, the regolith. Does this like completely blow the lander apart when it takes off? So then there's no more useful payloads after that, or can you still do stuff on the lander beyond that? Can it coexist, or is it the only payload?
Yeah. And you get a rapid iteration cycle too, because like back and forth to the moon a lot easier than back and forth to Mars, right? So
that's always been my biggest thing about like the moon and Mars stuff. It just like. Yeah, regardless, actually, I chatted with Andrew Jones on MECO earlier today, Jake, about Chinese space program, and he was trying to convince me that they're not wasting time in low Earth orbit of their space station, and they're not going to get stuck because they are getting a lot of like engineering and integration and operational reps. And that's the same thing with the whole moon to Mars debate. It's like, I get that, yes, not 100% of these things line up from the moon to Mars, but if it's right there. Like, there's so much we could do, and it's right there. It drives me crazy that we're not doing stuff on it regardless, and we'll get so many reps in. And yeah, think about at the end of the first iteration of Eclipse, the collective experience base that has been built up Another thing I always rant about is like companies don't have experience, the people do. The amount of people that will have worked on a mission that went to a planetary body will be enormous compared to where we were when we started it. And that has huge benefits, that whether or not the same engineering thing works in both places, the people do. And that has huge benefits as well.
Yeah, it's an argument to say that like something like Eclipse program is just a package around a way for NASA to train a really great engineering talent workforce, right? Like you're just getting a whole bunch of people that get to do real on the ground experience flying missions and doing stuff in space, right? And whether the program amounts to anything, those people still come out of that, and then they go on and found companies and make amazing stuff, right? So,
yeah, if you look at like just the sheer number of payloads, not to mention the vendors, the 40 something, 50, almost 50 payloads, payload teams, all of those people getting flight experience, all of those people getting, real world, space mission experience. It's really amazing to work on this program and to see that.
Yeah, well, I mean, science perspective too. Like we're talking to engineers right now, but you're exactly right. Like scientists, I mean, how you tell me as a planetary scientist, how many opportunities in your career do you get to be a PI for an instrument that goes to another planet? Like for many people, that's a 0 to 1 number, right?
Yeah.
Like,
It's a lottery ticket.
And so, just the opportunity to just like blast these payloads like rapid fire at the moon is like a great way to give a whole bunch of scientists opportunities to like, execute an investigation end to end, which is pretty cool.
Yeah, and considering most of that work happens before even launch from the PI side, and all that preparation and all that that experience, that's not lost. That's somebody's somebody's banked that, and they could take that to the next project, and it'll make the next project better. So.
Yeah.
I got some things. I got some questions here that I may or may not be circling 20 minutes back in the show, but you mentioned that the first couple Eclipse missions were the shots on goal mentality of like, try to get some payloads that, I mean, we'll say it, are likely to crash on the moon. And we either got more of them or this one wasn't that expensive in the first place, so we can fund another one. There's probably there's tiers of payloads of like, you're not going to send Viper on the first one, the first Eclipse mission. Like, we're going to wait on that one for a minute. But how does that come up against, like, or how do these two tracks either coexist or diverge, where over time, the more Eclipse missions that go, you want to like work your way up the tech tree of payloads, but at the same time, you might be onboarding new Eclipse providers or new landers altogether. Are there these tiers that could kind of be sorted out, and it's like these are first flight appropriate payloads and these are second flight appropriate payloads? Because you're going to have, in a handful of years, the third Intuitive Machines flight flying at the same time as the first Draper, first Firefly, or whatever. So how do you manage the like different payload lanes that there are in a world where we might onboard 8 Eclipse providers in the first 10-year segment?
Yeah. Let's see. I got to be careful here. I'm not going to speak for how we, are really super, the overall philosophy here. Just in general, it makes
Paul's
sense.
half-baked segment. From this point forward, Paul's half-baked ideas.
No, this isn't half-baked. This is just, I'm going to answer that more in general, I think. So in general, it makes sense that we don't have too many vendors in the final pool. So if you give out if you have 8 different vendors all doing things, then none of them will get enough money to survive, because there's just not enough money in the overall pool to support that many. There's obviously a strong desire at NASA to get as much competition and as much innovation as we can in. So there's that balance that I think people are trying to strike for how that works. And then obviously, as we move forward, I don't think that I've sort of, I don't think there's any kind of element as far as like after these first couple missions. I think that we've pretty much moved on, and we're the RFPs that go out are the things that we want to fly, and and we pick the best vendor for that flight. There isn't any kind of worry about path performance at this point.
Yeah. Well, I guess that tracks with what you said about trying to make sure that you're funding multiples of these payloads in the first place to get more benefits. Because either you're able to refly it or you can fly it again to a different spot altogether, and both are successful. Like, there's no failure scenario if you were to fund every payload 3 times. You know, the failure scenario is we got data from 1 spot rather than data from 3, but not we didn't get data at all, and this was wasted money. So
and past performance is something that we haven't in the past used, but is something that is going to start becoming something that is added to the mix. So that's I guess it's probably going to. I'm not in charge of that. So, but
flipping it on its side, like what I would think would be that you don't having a requirement like you must have flown X times is silly in a way, because amount of flights isn't a requirement. Like, what you're asking for is a certain level of reliability or robustness, and you prove that whether through a capability demonstration and testing or from relevant flight experience. Like, the way you prove that can come from different directions. But at the end of the day, you guys probably just say, like, we want this level of, assurance that our thing is going to get to the end, and tell us how you're going to do that. And then you look at the proposals. Like, that's just how it goes, right? So
that's true. Because right now, based on, like, if you had a payload that needed to be on the top of a lander facing up into the sky, neither of the competitors that have flown yet have done that. So, like, which one would you? It doesn't matter, Like, we're both still working on that, staying vertical situation. So,
so the LRA is the best example of that. That's the lunar retroreflector. That sort of passive thing that you could shoot lasers off of to get ranging.
I will never understand that, by the way. Like, I will never understand how those things work. I'm never going to look it up. I just like thinking that it's magic. That's how I appreciate LRAs.
It's just a mirror, man.
I know, but to some extent, it feels magical. So whatever.
There is optimism that it will work for the IM-1 mission.
Again,
so
see my comment. Those things are magical. I don't understand.
You bounce it off the moon underneath the lander to hit the retroreflector and then back up.
I don't know.
Again, I'm never going to look this up. I'm going to keep it magic. This is how I prefer to interface with these.
Oh, wow.
I have one other. Go ahead.
Yeah, go ahead. No. Go ahead. Shoot.
This was something I don't know if we mentioned this the last time we were talking, but in a situation relevant to you as having interacted with the Peregrine mission, you get like a day into the mission, right? And it's clear you're not going to the lunar surface. What is the process? I think we were spitballing this with Elizabeth, which is probably when you emailed us, but what is the process for running through the payloads that you have on board and saying, we can't do this mission that we thought we were going to do. We could probably do this set of missions. Who could make use of these things? Is there a process for that today? Is this something that is weird and it totally depends on what the situation is? Or because I did see a thing in Space News today. Jeff Faust wrote from the Woodlands, Jake's favorite place in America, I think. That here are the payloads that return data on Peregrine. So what was the process like for understanding who was going to be able to make use of a high elliptical orbit?
Yeah, so that was from a session that we ran at LPSC, so which was really successful. And we got to present, the payloads got to present some of their preliminary results. I think Jeff was in the room for it. So before the mission started, we actually had a whole conversation in the payloads about contingency planning. And we actually brought up the situation where what if the spacecraft doesn't make it to the moon and we're left in cislunar space? What kind of operations would you guys want to do? And so we had that whole conversation. One of the payloads told me I was crazy, and this is, we should tell you about it. So, not to be named, but PI told me I was crazy. But it turned out that was exactly what happened, and we were able to really rely on some of those initial thoughts that we come up with. One of the biggest challenges that we faced was that the mission was never designed to operate the payloads in cislunar space. So the spacecraft had a lot of features in it that were designed to only be useful on the surface, that would enable a lot of the payload operations. So that was a real challenge for everybody involved, and all of the people came through. The astrobotic team and the NASA payload teams really came through in amazing ways to enable all of that data to be collected. So it wasn't just we'll just turn it on and collect the data. It was never that easy. So and especially given the power and the data constraints that we had. So yeah, that was a process where that was what the project scientist was supposed to be there for, is to help manage the process of who gets to operate first, who gets to operate second. How do we prioritize the various things that we want to accomplish in a situation where we're not going to get everything that we want?
Yeah, that's interesting. The contingency planning, that strikes me as like a thing that is both like really fun and really tragic to think about. Like no one wants to like go down that path. Like, what's going to happen if this doesn't go the way I want? But then it's like kind of interesting. Like, oh yeah, well, like, what I could do is all the juices start flowing. Like, well, actually, if I did this and this and this, I could actually get some data that would be in some way useful. Let's try that. Let's go for it. So that's kind of an interesting thought process. That's probably a fun meeting to be in. I don't know if you guys did like if you workshop.
Sounds frustrating to me.
Get a bunch of pizza and donuts and just get a whiteboard and see what you can come up with. But it's kind of fun.
Yeah, in a way. And it turned out it was really interesting. Like so, PITMIS, the mass spectrometer was able to collect data on the the degree, what the nature of the stuff that was flying outside of the spacecraft was. That was really something that was actually operationally interesting. Same with Nervous. The pictures that Nervous took were operationally interesting for everybody involved. So the NASA payloads were able to sort of do a little bit of help out on the operations side.
Were there more ideas on what to do in that time than there was time to do it before Peregrine was sent into the Earth atmosphere? Did you have more of a list to work through, or was that you kind of like, well, we got what we could in that orbit?
Yeah, I mean, there was the amount of stuff that we could do with the instruments in orbit. I mean, these were all designed. I mean, we were all thinking about operating them on the surface. Obviously, there were a variety of things that were coming up with operations. The radiation instruments were really interested in operations through the radiation bands. I'm a geologist, so but the various radiation bands were on Earth. There were obviously more information would have been interesting from PITMIS as far as the cislunar space environment, especially if you could kind of get rid of the background that we were seeing. I'm not sure that would be so useful, but obviously all of the experiments wanted to operate as much as they could to get as much information, because they're going to operate again. Almost all, I think all of them will fly again. So all of the operational experience was useful for the future.
Is it even like I imagine it would even be useful just to like power it up and just send some information back and forth and just turn it on and use it, whether the data is useful or not, just to have that that operational experience of doing it while it's actually in space somewhere far away, right?
Yeah, we did some operational tests where we actually when we had the lander at Astrobotic, it hadn't been shipped yet, and they actually like plugged it in the antenna into a thing so that the antenna was shooting. We were broadcasting through the antenna back to Astrobotic, and there's obviously it went to like a computer rack, and that computer rack was simulating DSN. There's a lot of things that weren't particularly realistic, but at least all the instruments were on the lander and they were operating. They were using the power that was from the lander. So all of that was really good. And then so doing that again in space where everything was operating on its own, that is an extraordinarily valuable experience.
Interesting. Wow. Okay.
What's the next thing that you're on? That's what I'm.
That's the next thing I'm on.
Yeah.
So I think I'm stepping away from Eclipse a little bit. We'll see.
Working on the sample return. Just going into
No.
PI mode.
No, it's the origin. I do actually have a lab. One of the things I do, one of my other hats I wear, is we run a triple oxygen isotope lab where we analyze samples from various places. So meteorites and Martian meteorites. We're interested in understanding. So we're really interested in Mars samples. When they come back, we'll have a lot of interesting analysis that we could do with that lab. But yeah, my next step is I've been working a lot on. So I want to kind of try and focus more on the science and then focusing on the other hat I'm wearing is I do human science objectives, human science planning. So for planning for science on the moon, on Mars. I'm sorry. So I've been assisting with some of that planning. So we did a science objectives workshop a couple of years ago, and so we've been involved with trying to formulate what the science objectives for humans to Mars is going to be. So that's an ongoing process. So
Yeah. An
Sure
ongoing
is.
process. Yes, it sure is.
It's a journey, some would say.
it's a whole other podcast. It's a whole other.
Used to be. Once and future.
Oh dear.
Yeah.
Okay. Well,
You're wearing the hat. You're going
I
to get
am
shit
wearing
for
the
it. You're
hat,
wearing the
yeah.
hat. Yeah.
I even have. I think this is a Mars shirt too.
Oh, yeah.
So
Yeah.
There you go.
I asked for it today, but no, this is great, Paul. I'm really glad you came on because this has been helpful. I may have more questions. I'll have to kind of think about them. We might have to do a round two. We'll think about it and see what we come up
I have
with.
a few.
But
Yeah.
but this is good because now I can think about these in sort of different ways.
Sounds good. Very good. Thanks for the conversation. It was really interesting.
Yeah. Next week, Anthony, you are not around, right? Am I getting
Correct.
scheduled right here? Yeah, you're off on a trip somewhere.
A 4-year delayed trip to France. Yes.
To France.
I had this
Yeah,
trip booked
okay.
in April of 2020 and I never went. So here we go. We're doing it.
Good, yeah. So I will be running the show, and it's going to be We Martians Takeover.
Shocker.
We've got Planetary Science Takeover again. So one of my friends, Simon, is coming on the show. He was at LPSC, as we mentioned on the show today. He's going to give us a little bit of a on-the-ground report about things that went on. There's some interesting stuff, I think, about sample return and maybe Starship and why that is at all related to planetary science today. So some fun stuff to talk about. So that's what we're going to get into.
I wonder why. There was,
Yeah,
and nothing relevant in the last week or two that
Nothing
everything went really
happened
well
last
with.
week ago,
No, yeah.
So,
I'm still like mind blown over the imagery from that flight. It was so good. I keep watching
real
it.
Good. Yeah.
It was so good.
I'm still waiting for. I want a night launch so that I can stand up on my roof and see it. I think I'll be able to see it, but just not during the day. It's been too bright so far. So we'll see.
I mean, or we should just go at some point.
Yeah, or we could go. Yeah, we could get off
We
our
could
bus
go to
and
it.
go.
Yeah. It's just that I'm not in a point in my life where I could get an FAA license one day and be there the next. I'm not at that spot.
It's tough.
Because there's a kid in my life that really likes Starship, but I will have you know, I've mentioned this before, that he really just wants to watch the Falcon Heavy demo mission, and even when I showed him Starship, he still wanted to watch that. So it's not even like he's a SpaceX homer. He's just a Falcon Heavy kind of guy. So yeah, we should go to the.
I mean, it would help if they put the launch site somewhere remotely accessible. So that would be good.
Yeah. Is that the guy who lives in Mexico? It's like a pretty bizarre statement.
Yeah, I mean, you can literally like fall off the rocket into Mexico. It's that close, and yet it's still very far away.
Impossible for you.
Very far away. Yeah, still impossible.
All right, y'all.
Cool. All right.
Off-Nominal.com/events. Go meet up with Jake.
Events.
Hit me up if you're in Dayton. Yeah, it's gonna be great. The Eclipse is gonna be great. Are you going anywhere? You're probably going nearby, Paul. You've got a short drive. I mean, it's probably as long of a drive as I've got, honestly.
Yeah.
It's also 9 hours.
Texas, which may as well be Oregon. So.
Yeah, it's the whole way across the country. So yeah. All right, everybody. See you later.
All right.
Bye.
Bye, everyone.